All right, we got yet another Lowrance HDS7 on the bench. This is actually a different customer. It's not the same as, what was it, Ticket 510. Same issue though, will not turn on. Although, as soon as I took this out of the box, I could smell burning silicon basically, or burning electronics. It's a very distinct smell, and I can smell it all over this unit. Very, very strong. What I'm going to do is hook up power real fast. Based on the smell alone, I'm sure that this thing's going to be shorted. And as soon as I plug it in, yes, I'm getting 5 amps. So let's not do that anymore. We're going to take out all the T8 screws, take out the plastic nuts, and get the back taken off and see what's going on. All right, we got the back off, and this thing smells awful. I've never smelt anything, any burnt electronics this bad. It's nasty. I have no idea. Well, that's why I guess the plastic connector is just melted. Let's see if I can get this under the microscope. Just disgusting. Like, oh man, freaking gross. Where am I here? See. Well, there's some of the plastic melted on the board. Can't really see the connector, but obviously that chip is gone. Whew, man. Smell coming off this thing though. Oh, super gross. I don't know if you can see that, so let me get something to point with. So this connector right here, this is our main power connector. Melted right here. You can see char all under the board. The board's toasted under there. I guess when this liquefied, it ran across the board. Either took out that chip, or the chip is the reason, why this smoked. I'm not sure at this point. So we're gonna go ahead and take the board off and take a good look underneath. And I'm gonna go turn the fan on. Oof, man. Okay, we're back again. We got the board off. Take a look at that. Totally melted. There was a lot of current going through this guy. I'm wondering if the customer didn't have an inline fuse hooked up to, come on, focus. Focus. Hooked up to his 12 volt line coming into this fish finder, because that is crazy. Crazy. Let's move the display aside so you can see under the microscope here. Look at that. Gross. Oh, man. I've just never seen that before. It's so strange. Look at the back side of this board. Check this out. Look at that. Oh, man. This is really bad. I mean, I'm hoping we could salvage this, but at this point, I don't know. Look at that. The board just disintegrates. Jeez. Crazy. All right, what we're gonna do here is we're gonna clean up all this burnt board as best we can. Clean everything up. See what's going on in the front here. Clean all this up here. We're gonna go ahead and take the main power connector off the board completely. See what's going on underneath it. I'm sure just tons of char. And we're gonna see if we can pull a rabbit out of our hat here and maybe possibly fix this thing. I would say at this point it's like a 20% chance of this thing coming back to life, just the amount of damage to the board. But we're definitely gonna try. Even if it was 5%, we're still gonna try to get this repaired for the customer. We just gotta be careful how much time we spend on it, obviously. And jeez. Whew! Dang. Alright, we'll get back with you. Okay, look at this. The board disintegrated. Oh my god. You see this? There's no more board. There's no more board. That's the connector. Holy. Look at that. Wow. That is insane. The camera doesn't do it justice. I mean, this is nuts. Let's see if I can get this. Oh, I'm on the wrong camera. Hold on. All right. Oh, come on, focus. Look at that. The board's gone. There is no board. Okay, so obviously cleaning isn't gonna do anything here. We gotta get this socket off the board, this power socket here. Looks like somebody took a blowtorch to this thing. It's crazy. Might be wasting our time here even attempting this. Oh man, the stink coming off this thing. Whatever that smell is, I probably shouldn't be breathing it in, I'm assuming. Man, holy hell. Jeez. Try some heat. It's not going to hurt anything at this point, I guess. Oh my god, holy crap. Woo! Dang. Look at that. That's the connector right there. Or the socket, rather. Look at that. Look at this board. Look at that. Jeez. That's crazy. Alright, I'm gonna clean my bench up a little bit here. Get some of this nasty stuff off here. Clean the board some more. As best as we can. And we'll get back with you. At that point, once the board's cleaned off, we're gonna try to apply power directly to the board itself. If we have luck doing that, we'll probably keep going, keep chugging away on this thing. If we apply power and traces are smoking and stuff, we might call this one. I don't know. We'll see. We'll see. We'll get back with you. All right, so we cleaned this up quite a bit here. This is our donor board here, little HDS7. We salvaged the connector from our donor here, and cleaned it up real good here. Looks nice. Okay, it's gonna be a good donor for here. It's obviously the original junk, no good. This is the board after we cleaned it up. This is about as clean as we're gonna get it here. There. So on these power connectors here, it's not just power. There's also two COM ports, COM1 and COM2. Both is RS-232 serial communication. We asked the customer if he uses these units, uses this unit to communicate with a second unit or multiple units in the NEMA system. He said no, this is the only unit he uses. If he did use multiple units or he needed those COM1 and COM2 ports that are built into this connector, we would have to do some more work here. So if he does not use those, which he doesn't, we kind of don't have to worry about those pins. There is a chip here that's toasted, so we got to check to see what that chip was. I'm thinking, in fact, I think this is the same chip on the donor. It's in a different position though. Maybe that's the maybe that is part of the RS-232 communication circuit. We'll have to double check that. If so, we could probably just remove it. We should be good. So we're gonna get to it. We're gonna install this guy. Actually, you know what we're gonna do? Before we go ahead and do that, we're gonna go ahead and take our donor board, just in case we have future units that have issues with the power connector, or maybe if customers are having issues with COM1 and COM2. Anytime we have a unit, we try to learn a little bit more about the circuit and about the board, and we note that down for future use. It just helps us understand the circuit of these more, which obviously will help us troubleshoot and repair these circuits. So the more information we can sort of glean from these repairs, the better. We obviously don't have any service manuals here, so we got to do all the investigative work on our own, sort of like reverse engineer parts of the circuit when we need to. So in this case, I know that there's some RS-232 communication going on here in addition to the, obviously, positive and negative supply coming in here. So what I want to do is figure out where these other pins, I know these two, this is power up here. Here, let me get into the microscope. Okay, let's switch the microscope over real fast. Okay, so I know this is the positive 12 volt supply. This is ground. All these other pins are part of that RS-232 communication, from what I can understand. So how are we going to see where these go? This is a multi-layer board, so there's nothing on the top layer, obviously. We can't see anything, right? If we look at the bottom layer, we do see our power, so we see our ground here, and we see our positive supply going to the fuse. That makes sense, right? And we can double check that ground. Just put our meter in continuity mode. Go here, and then we'll go on a known ground. So let's say this shielding material right here. So if you can hear that beeping, so that's our ground. We knew that. But look at all these pins. I mean, where do they go? The traces are in other layers of the board. Again, multi-layer board. So how are we going to figure that out? Well, luckily, there's no ground plane on the top here. And there's no ground plane on the bottom. So, what we've done in the past when we sort of had to reverse engineer parts of a circuit, whether it be for repairs or, you know, trying to find a JTAG or RS-232 port to test the security of an embedded device, something like that. A cool little trick is we can use light. We can shine a bright light in there, and we should be able to see some traces in here. Let's try this. You know what I'm going to do? I'm going to have to build something real quick. So I have some of these LEDs. Here, let me switch back over here. Give me a quick sec. Okay, so we have some of these LEDs that we use for building backlights for these units. We've built quite a few custom backlight strips with these. I think this, let me see, these are 3 watt. And I have another pack over here, and I also have different styles and everything, but style doesn't matter in this case. So these are 3 watt, these are 1 watt. Let's use the 3 watt, and let's build a little board illuminator, because I'm going to be able to use this not only for this specifically right here, but I'm going to be able to use this in the future if I want to see where traces are going in a board, you know, whether that be for security research or just repairs. So I'm thinking maybe, I don't know, maybe 3. Maybe 3 will do it. Maybe more. I don't know. I'm gonna pause the video here. I'm gonna come up with something, just something very quick. We're not gonna etch a circuit board. I don't have time. We're kind of taking a detour from the repair, but I think you know, using a little bit of time to make this little light and figure out where the communication ports are going here. I think it's worthwhile. So we're going to pause, and we'll get back to you once we have something here. Okay, so what we did was just took a piece of copper clad board. This is just for my own testing. It's not for a customer, so obviously we're just going to do this quick and dirty. It's not going to be pretty. Hopefully it's going to be functional. Piece of copper clad board. We took a little cordless rotary tool, cut it out. We cut a line, actually 2 lines here. Basically very simple. It's just to separate electronically or electrically the right and left side. It's going to be a positive and negative. We're going to have a current limiting resistor in there, and that's pretty much it. We're going to throw probably some heatsink compound along the center here underneath these LEDs, so it'll work as a heatsink as well. It'll dissipate some heat. And that's it. So let's get it done. Okay, so we finished making this. It's basically just a light strip. Nothing special here. Just a bunch of LEDs in parallel. Made a note for myself. We don't want to go over 3 volts for this. 2.7 to 3 volts should be good. And what we're going to do is we're going to have some light bleed through on these holes here. So what we're going to do is we're just going to fill the pads with, fill the through holes with solder. That's normally where the connector would sit there. And what would happen if we didn't do that? The light would just shine through and kind of white out the microscope camera. So let's do that real fast. Okay, done. Not that we really have to, but we'll just clean it up a little bit. Oh, we missed one. Missed one hole there. There. Okay, let's get our power supply at 2 volts. It's around 3 volts right now. It's good, because the max is 3. It's just a light. You could do the same thing with a bright flashlight. I just don't have a flashlight in the shop here. And this is kind of where the magic happens here. Because there's no ground plane on the top and the bottom. Watch. Let's check this out on the microscope. And we put the light underneath, and like magic, it's hard to see, but there, it's a little bit better. Let's adjust the light. I think the light's a little too bright for the camera. There, perfect. Okay, so we can kind of see here what's going on. This is ground. This is power. You could barely see some big fat traces underneath on the bottom side of the board. Now that's on the opposite side of the board, the back side of the board. These traces are a little more crisp. They're not on the top, but they're somewhere in the center of the board, sandwiched between, the multiple layers of the board. Because there's multiple layers inside the board, you can think of it like a sandwich. I'm not sure exactly how many layers, but there's several layers. It looks like these traces are crossing each other, but most likely they're not. There's just multiple layers, and we're kind of getting that view as one. So if we take our meter, go to continuity mode, we can verify that easily. Let's touch this one, and it looks like this trace is going to this pad here, but it's not. Try that. No. No. Let's try our ground. Nope. Okay, so let's try to find our ground first. So we know this is the known ground, right? We already checked this one, nothing. Oh, that looks like a ground right there. Let's keep going. No, 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 no. Obviously no. So this pin is a ground. Let's see if we have plus 12 anywhere else. So this is our plus 12 volt. We shouldn't, because it should be, as far as I understand, it should be 5 volts, not 12. 1, 2, 3, 4, 5, 6, 7. No, so we don't. So that's correct. Now I'm trying to figure out where these traces are going to. Now we can't see because the ground plane starts around the circle, so we can't tell where they're going. It looks like these traces are going to the right. It just looks like that. And the closest components to the right, I mean, there's some discrete components. You know, there's some semiconductor components over here. And there's a chip right here. So let's just randomly pick, I guess right here. That wasn't our ground, nope. And I'm just gonna swipe across the chip, see if we get any beeps. We did. The last pin of that chip right there. Okay. Check the other side of the chip. Nothing. Okay. Let's move to, I think this was our ground, right? Yeah, so we can ignore that. Let's try this pin here. Since we had luck on this chip, let's check this chip again. Oh. Right there. It's that third pin over. Keep checking. Nothing. So that third pin. So we're getting somewhere here. So obviously the RS-232 communication, the COM1, most likely COM1 and COM2 both, go through this chip first. This chip could be some kind of buffer. It could be a level converter. I don't know. I'm not sure. I haven't looked. In fact, I'm not even going to get that deep into this. I want to know just roughly where these traces go. So we could go further. We could check the data sheet, try to find a data sheet on this chip, figure out what this chip does, and move on from there. You know, if it's a level converter, we could figure out from that chip where is the signal going, etc., etc. And maybe in the future I will play with the NEMA serial communication on one of these guys, but I don't have the need right now. It'd be more of like a fun little project than anything. But if the need arose, we'd know where to start our investigation. That's why we're doing this. So let's try this one. Swipe across this chip again. Okay, so it's the last pin on this chip. Let's try this pin here. Nothing. Is that no connection? It looks like there's nothing connected to that pad to me. So I think that's a no connection. I think this is another no connection. Let's check. Nothing. I don't know if we check this one or not. Let's check it. Yep, it's that second pin. Great. Okay, so let's move to here. And that's going to be on the other side of this chip. So I'm convinced, obviously, that this chip plays a very important role in the RS-232 communication of COM1 and COM2 on that power connector. Okay? So now that we know that, we're done with our donor board here. I'll put that back with all my other parts boards. So now we can get back to our board we're actually working on here. So let's see. Okay. So let's zoom back in here. Okay, so we know where our power pins are, obviously. here and here, no problem. Now our other pins. So let's see how similar this is to the other board. Now don't forget, this is a 7, our donor was a 5. So not the same board. So on our donor, that communications chip was around right here. What I'm thinking is it's right here on this board. And why I think that, I hope makes sense, because this component's bad, obviously burned up, right? Trying to figure out why this happened here. Okay, I talked to the customer. They just had this fish finder on their table hooked up to a battery, and they asked me, well, you know, if I accidentally reversed the positive and negative, could this happen? Well, it could happen. Usually it would blow a fuse before something like this happens to this extent, but it got me thinking. I wonder if it wasn't a polarity issue. I wonder if the customer accidentally connected the comm lines, because it's all part of the same harness, it's all part of the power harness. I wonder if they connected the comm lines to the 12-volt supply. That would account for the communications pins to start toasting, because what it probably did, it probably immediately took out this chip. And this chip is probably shorted, which means these pins are shorted, which means most likely, you know, there was a short from the power supply directly through here, back to here, causing heat right here. Prolonged heat will obviously do this to the board. Again, I've never seen to this extent, but it's possible. Just a theory. That's what I think happened here. I'm not positive, but I think so. Now, what I would like to do is try to figure out if those traces do in fact go over here. Now, it looks like this might be the ground plane, but I don't think so. I think that's one of the communications traces. Now let's try something. I'm going to put my probe on that trace that I think is communications. Look at that. So I bet that's the chip right there. Bet that's it. So what we're going to do here, I talked to the customer. He doesn't care about the NEMA serial communication at all. So what we're going to do is we're going to remove this chip, because this is obviously bad. We're going to pop that guy out. We're going to put the power connector back on. We're going to solder the positive and negative the best we can. We're going to repair that trace there. And then we're going to backfill this thing with epoxy to give it that extra rigidity it used to have, because now there's no places to solder those communication pins to. Even if we're not using the communications, it was still, you know, mount points for that connector. So let's take some low melt solder here. So we're working with a lot of plastic components over here, so we want to limit the heat. There, look at that. Beautiful. So there goes that. Let's clean things up a bit. clean this area up a little more. There. All right, here's our connector here. Let's see what we can do. Okay. What I'm gonna do, you can't even see it here. Let me fix that. You can see that okay. We've got 1, 2, and potentially 3 mount points right there. So let's get our iron. Let's get some solder on our iron here. I'm gonna do this off microscope just because I gotta hold it from underneath. Okay. Let's get back under the microscope. There, so. Okay, I'm gonna get a rotary tool and a bit on there real quick. What I'm gonna do is I'm gonna grind this trace down here just to remove the conformal coating, that top coat. Once all that top coat or solder mask is removed, we'll run a wire along this track. Around here, we'll solder this really well. I'm going to check this track here because that doesn't look too hot. If there's no breaks and it's good continuity, we're going to leave it, but we're going to take some solder mask and put it over that. Then if everything works good, all the connections look okay, we're going to try to fire this thing up. And if it works, excellent. If not, we'll see what's going on. If it does work, though, we're going to come back here and we're going to fill this guy with epoxy. So let's do it. Okay, the power connector's on. We're gonna get this back together. I'm not very hopeful this thing is gonna turn on. I mean, there was such bad damage to the board. I've never seen damage that bad before. And when we took this thing apart, I mean, I've been around burnt up electronics for so many years, but I've never smelt anything like that before. It was horrible. I think the smell was the plastic. Whatever kind of plastic they use gave off a horrible toxic odor. Super bad. So here we go. We got the display hooked up. Got the power button. We should be good. Let's make sure we're at 12 volts because we were at 3 when we were messing with that light. Let's see, we're at around 12. Perfect. Talked to the customer when I was talking to him. He said even if he gets another season out of this, even if he gets half a season, he'll be happy. So obviously our goal is better than that, but the way this board was, well, that's the first good sign. We just plugged in power, and we have no shorts because my power supply shows zero current being drawn. So let's see what happens here. I'm monitoring my power supply very closely. If I see any hint of a spike of current, I'm gonna turn off the power supply. Fingers crossed, but this probably isn't gonna happen. In 3, 2, nothing. 3, 2, 1, nothing. Okay. Well, let's see if turn the power supply off. Our fuse is good. Let's make sure we got positive rail. Is not going to the fuse. Look at that. Well, let's see what we did here. Let's see what's wrong. Did we forget to do something? Now this is a multi-layer board, so even if we connected the bottom pad, it doesn't mean the top trace is connected. So let's see. So the positive side is the side we repaired. We can see that right here. So that makes sense because we're connecting the bottom side of the board here, but it seems as though the bottom positive trace here for some reason isn't electrically connected to the positive side of the fuse. So let's just confirm that. So again, positive side, nothing. Okay. Let's check positive side of the repair we did down here, where we repaired that track. Okay, that's correct. So we have a good connection to the pin. I'm checking the other side of the fuse, nothing. Nothing. So let's fix it. So what are we gonna do? Well, I think I'm gonna do this. Let's get another piece of wire here. Piece of hookup wire. Doesn't have to be anything special. You know what? We could even use this stuff here. This is there's an enamel on this wire, so this will be good. So we don't have to worry about insulation. We're gonna come off here. We're gonna solder to here. We're gonna come around the board. In fact, we might be able to sneak this guy. Might be able to sneak this guy through the connector, possibly. Let's see. I think that's what I might do. I'm going to melt a small hole. You should never do this with a soldering iron tip, but I'm going to do it. I'm going to melt a small hole in this. Geez, that's really heat resistant stuff. That's good. So I'm going to drill a small hole. That's what I'm going to do. Actually, you know what? We have a screw hole there, right? Let's see. Let's see. Yeah, that screw hole is unused, so let's just do that. We're going to come through this hole right here. Because it's not currently used on the board, so that's perfect. Piece of the wire. So let's come up here. We're going to come around. Right to there. Now we're going to have to melt off the enamel and tin the wire, but we can do that right from the iron itself because it gets hot enough to do that. Let's see if we can get a... There. You can see that enamel kind of boiling off. Beautiful. Okay. Perfect. That looks good. Let's go around the other side here. Let's tin this side too. Get some of that enamel off the tip of that wire. As soon as the enamel's off, it'll start to tin. Just like that. Throw some flux on that fuse there. We're gonna add some solder to that side of the fuse. Well, kind of like that. So, let's check it again. Make sure we have an electrical connection from the positive pin to this side of the fuse. We do. Let's check the other side of the fuse to make sure it's good fuse. It is. Let's plug the board back in and see what happens. If the board or if the unit does not power on at this point, we're going to have to seriously consider calling it quits on this one. It's just, we've spent a lot of time on this one already. We've spent more time than we estimated the customer. We're going to keep to our estimate. So at this point, you know, we're getting towards the part where we're going to start losing some money here. And that's kind of not the point. We're trying to feed the kids. So we want to avoid losing money if we can, obviously. Okay, so now we have to be careful again. Now we have a connection from the fuse to the positive side of the pin. We want to make sure that there's no shorts in here. So I'm watching the power supply. We look okay. Zero current being drawn. Again, hopefully. but I doubt it. 3, 2. Wow. Amazing. Amazing. That was the connector right there. A hole in the board the size of a dime, clear through the board. And this thing is booting? Wow. Awesome. Backlight works. Display works. Look at that. We did it. We fixed it. I did not think that was going to happen, but you know, we didn't give up. I'm sure, I'm positive any other shop, it would have went back. It would have been a no fix. I guarantee for any other shop. And any potential repairs you might have, you want to get an estimate, go to the website rudolphrepairs.com. If you want an on-bench estimate, fill out the form, send it in, and we'll give you an on-bench estimate for free. If you want to go ahead with the repair, we'll go ahead and do it right away. If you want it, if you don't want to go ahead with the repair, we ship it back just for the cost of shipping. There's no charge for on-bench estimates. We also have a no fix, no pay policy. So it's in our best interest, ours and yours, that we repair these units. So any questions? RudolphRepairs.com, RudolphRepairs@gmail.com. See you guys later.